Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. In the regression output, we saw the left-hand corner and the right-hand corner block of on top of the regression table. In the previous video, we talked in detail about the total sum of squares, explained sum of squares, and residual sum of squared, which were the elements on the left-hand side block. Today, we're going to concentrate on one particular element from the right-hand side block. In the regression output, this one number always gets a lot of attention, and this is the r squared. In this video, we're going to understand what r squared actually measures, and most of all, what does it not measure, and why it lives in this top right block of the output. Keep in mind, in this video, we're going to mainly see the meaning, the intuition behind it, and we're gonna dive into formulas in further videos. Let's start from the simplest. Imagine that you have not run a regression yet. If you have no regression, then the simplest possible way, like the simplest possible model about predicting, in this case, is going to be the mean of y for every observation. In this particular kind of model, you're ignoring any other x variables, you're ignoring any relationships that it gives, but you have sort of a baseline. Now, keep in mind, the r squared that you have in the outputs, in the sense, is comparing your regression to this very simple benchmark. Getting back to our definition for the total sum of squares. This total sum of squares was not related to the model that you were constructing. This was only related to your outcome variable y, and it was how far observations were from the mean. So this is the variation that we want to explain. And here you have not run a model yet to see. You're just looking at the dispersion of your y variable. So once you run a regression into this picture, meaning you're adding more relationship, you're adding more x variables, you are adding more elements to it. So that's why we have the explained variation from the x variables, and then some of that is still left in the residuals, which is why you had also the residual sum of variations. This is where the split happens. Now, why do we need the r squared at this stage? Well, the r squared is defined as the fraction of total variation explained by the model. And now that you know the definition of it, and you also know all of the elements, the explained sum of squares, a residual sum of squares, you can very easily derive the r squared formula from here, because that just means your r squared is the explained sum of squares over the total sum of squares. Okay? How do we interpret? So we see a number in our output regression, and that is r squared, let's say, equal to 0.50. What that means, simply that 50% of the variation in y is explained by the model. Okay? So keep in mind, in this case, when you're saying like explained in this definition, you mean statistically accounted for. I am not saying, or your output is not saying that that is causal, but what it's statistically accounted for. And this distinction matters a lot because the r square is not really indicating to you whether you have a causal relationship. It's just saying this much of the variation can be explained because of the variation that is happening within these other x variables. And then you can take any numbers, but I also want to stop a little bit more into the extremes for the r squared. So if we have an r squared that is equal to 0, and then an r squared which is equal to 1, what does that tell for us? Like, does that still not give us any causal and stuff? The answer is always, it's not going to give you any causal relationships. But for the R0, what that means is that the model explains nothing beyond the mean. Okay? And if r squared is equal to 1, which in most of the studies you'll notice that is never the case, and usually whenever we see an r squared which is equal to 1 or very close to 1, we always have to look a little bit beyond the model to see what is really happening for us to really be getting this kind of big number. But ultimately, based on the definition that we have, we would say that the model explains all variation perfectly. So, see, I'm saying perfectly. From here, you understand why you have to start to be a little bit wary if you see that in your actual studies. Most of the models that you will see will lie somewhere in between this 0 and 1. And keep in mind, r squared cannot be bigger than 1. The reason for that can be related right back to this formula. As you can see, this is a ratio, and we know that there is a relationship between the total sum of squares and the explained sum of squares, and we know that total sum of squares is bigger than explained sum of squares because total sum of squares itself is explained sum of squares plus the residual sum of squares. So this ratio in here, it's always going to be greater or equal to 1. Okay. Now, in Stada and R, which are the two softwares for which we saw the outputs in the previous videos, r squared will appear at the top right block of the regression output, and the placement is intentional. Keep in mind that this r squared that you have in this right block is about the model as a whole. Okay? So it's not about any of the individual coefficients, which then brings us to the question. So then, if this is telling us something about the model as a whole, is it something it is not telling us? And what it does not tell you is that there is a causal relationship. It does not tell you that the model is correctly specified. You'd have to do diagnostic tests for that. And most of all, it does not tell you that the estimates are unbiased. Okay? And most of all, one of the few very common misconceptions about the r squared is that a r squared, which is low, does not mean, it's not equivalent to saying that the model is useless. And it's not equivalent to saying also that the effect is not important. Okay? Especially in economics, where you are looking at more context related to these variables. Okay? So the best way that you should be thinking about the r squared is the following. How much better is the regression than just using the mean? That's it. I hope this was helpful to give you a better understanding of what the r squared tells you and what the r squared does not tell you. In the next video, we're going to look into the adjusted R-square and understand why plain R-square can be misleading. I'll see you in the next video.